Good morning. In this session, we are going to see a topic on steam turbines from the subject ME 8595 Thermal Engineering 2. Steam turbine, a prime mover in which a potential energy of steam is transformed into a kinetic energy and later in turn is transformed into mechanical energy of rotation of the turbine shaft. A turbine shaft directly or with help of reduction gearing is connected with driven mechanism. Based on the type of driven mechanism, it is used for power generation and transport. Advantage of steam turbine over the steam engines. The first one is the thermal efficiency of steam turbine is higher than that of steam engine. The power generation in steam turbine in uniform, hence flywheel is not required. Higher and greater range of speed is possible than in case of steam engine. The steam turbines are very much suitable in large thermal stations where we need higher inputs. With the absence of high reciprocating parts, the balancing problem is minimized. No internal lubrication is required. In a steam turbine, there is no loss due to initial condensation of steam. A steam turbine can utilize a high vacuum very advantageously. The considerable overload can be carried at the expense of slight reduction in overall efficiency. Steam turbine. The classification of steam turbine. First one is with respect to the action of steam. There are three types. First one is a impulse turbine, second is a reaction turbine, and third one is a combination of impulse and reaction turbine. Other classifications are, first one is according to the number of pressure stages. First one, single stage turbine, second is a multi-stage impulse and reaction turbine. Second, according to the direction of flow steam, there are two types. First one is the axial turbine, steam flows parallel to the turbine axis. Second one is a radial turbine, steam flows perpendicular to the turbine axis. And the third one is the according to the number of cylinders. There are four types. First one is a single cylinder, double cylinder, three cylinder, and the four cylinder turbines. According to the method of governing, first one with a throttle governing, the example are throttle valves, and the nozzle governing, the example is open regulators, and the bypass governing the first stage and intermediate stage. According to the heat draw process, first one, the condensing turbines with generators, condensing turbine with one or two intermediate stage of extractions. Third one is a back pressure turbine, and the fourth one is a topping turbine, and the fifth one is a backup pressure turbine. Next one is a low pressure turbine, mixed pressure turbine. Sixth one, according to the steam conduction at the inlet of turbine. First one is a low pressure, medium pressure, high pressure, and the turbine of very high pressures and the turbine of supercritical pressure. These are the steam condition of turbine. According to their usage in industry, the stationary turbine with constant speed of rotation, steam turbines with variable speed, non-stationary turbine with a variable speeds. Common types of turbines are simple impulse turbine and reaction turbine. The main difference between these turbines lies in the way which the steam is expanded while it moves through them. In a former type, steam expands in a nozzle and its pressure does not alter as it moves over a blade. In a later type, the steam expands continuously as it passes over the blade, thus the gradual fall in pressure during expansion. The simple impulse turbine. The top portion of the figure exhibits of the longitudinal section through the upper half of the turbine. The middle portion shows one set of nozzle which is flowed by a ring of moving blades. Lower part indicates the changes in pressure and velocity during the steam flow through the turbine. This turbine is called simple impulse turbine since the expansion of steam takes place in one set of nozzle. As the steam flows through the nozzle, its pressure falls from the steam chest pressure to condenser pressure. Next one is due to a relatively high ratio of steam expansion in the nozzle, the steam leaves the nozzle in a very high velocity. This is a diagram for impulse turbine. The velocity of steam leaving the moving blades is a large portion of maximum velocity of steam which leaving the nozzle. The energy lost due to its higher exit velocity is called carryover or leaving losses. The example of a simple impulse turbine is Lee level turbine. The wheel or rotor speed can be reduced by different methods. This is a diagram for impulse and reaction turbine. There are differences in moving blades. Reaction turbine. A reaction turbine is a type of steam that works on the principle that a rotor spins, as a name says, from a reaction force rather than the impact or impulse force. In a reaction turbine, there are no nozzle to direct the steam flow in an impulse turbine. The fixed blades, which are same shape as moving blades, are mounted to outer casing where the rotor revolves and to guide the steam into a moving blades. The steam enters through a section of curved blades in a fixed position. The steam then enters through a setting of moving blades and creates enough reactive force to rotate them. The steam exits the section of rotating blades in the direction of the rotation. It's a diagram for a reaction turbine. The gradual pressure drop takes place continuously over a fixed and moving blade. The fixed blades alter the direction of steam as well as allow it expand to a larger velocity. As the steam passes over the moving blades, a kinetic energy is absorbed by them. The change in pressure and velocity are shown. Since the pressure drop per stage is small, the number of stages required is much higher than the impulse turbine of the same capacity. It is a diagram for a reaction turbine. Method of reducing wheel or rotor speed. If the steam is expanded from the boiler pressure, in one stage the speed of the rotor becomes high, which crosses by practical complicates. The different methods of compounding are velocity compounding, pressure velocity compounding, and the reaction turbine. Velocity compounding. The rings of moving blades are separated by rings of fixed blade. The moving blades are keyed to the turbine shaft and the fixed blades are fixed to the casting. The high pressure steam coming from boiler is expanded in a nozzle first. The nozzle converts the pressure energy of the steam into kinetic energy. The high velocity is directed on a first set of moving blades as the steam flows over the blade. Due to the shape of the blades, it impacts some from the momentum to the blades and losses from the velocity. The function of fixed blades is redirect the steam leaving from the first ring moving blades to the second ring of the moving blades. There is no exchange in velocity of steam, it passes through the fixed blades. Advantages. The velocity compounding impulse turbine requires a comparatively small number of stages due to relatively large heat drop stage. Due to small number of stages, the initial cost is less. Disadvantage. The velocity compounding impulse turbine has low efficiency at high steam consumption. Pressure compound. The pressure compound impulse turbine is also known as a rotate turbine. After its inventor, this is used to solve the problem of high blade velocity in a single stage impulse turbine. In this type of compounding, the steam is expanded in a number of stages in a velocity compounding. Disadvantage of pressure compounding. The disadvantage of, since the pressure drop in a nozzle, it has been made airtight. They are bigger and bulkier in size. Pressure velocity compounding. It is a combination of about two types of compounding. The total pressure drop of the steam is divided into number of stages. In each stage, there is one ring of fixed blades and 3 to 4 rings of moving blades. Each stage acts as a velocity compounded impulse turbine. The fixed blades acts as a nozzle. The steam coming from the boiler is passed through the first ring of fixed blades, when it gets partially expanded. The pressure partially decreases as the velocity rises correspondingly. The velocity is absorbed by the flow rings of moving blades until it reaches the next ring of fixed plate, and the whole process is repeated once again. It is a pressure drop difference between the impulse and turbine. The particulars are pressure drop, area of blade channels, blades, and the admission of steam, nozzle blades, power, space, and the efficiency suitable and the blade manufacturer. In the impulse turbine, the efficiency is low, and the reaction turbine, the efficiency is high. Thank you.